Let's take a look at how to draw Bohr-Rutherford diagrams. These diagrams show what an atom of an element looks like, and it also indicates the number of protons, electrons, and neutrons that are present in one atom of the element. The first step in drawing a Bohr-Rutherford diagram is always to determine the number of protons, electrons, and neutrons present in one atom of the element. And we've done this before, and there's an instructional video that will remind you how to count the number of protons, electrons, and neutrons in one atom. So let's draw a Bohr-Rutherford diagram for fluorine. Fluorine has an atomic number of 9 and a mass number of 19. We'll use these two numbers to determine the number of protons, electrons, and neutrons. The number of protons is equal to the atomic number. So the atomic number of fluorine is 9, therefore there are 9 protons. The number of electrons in a neutral atom is always equivalent to the number of protons. Therefore, there are 9 electrons in one atom of fluorine. The number of neutrons is determined by subtracting the atomic number from the mass number. In this case, it is 19 minus 9, which equals 10. There are 10 neutrons in one atom of fluorine. Start your Bohr-Rutherford diagram by placing the protons and the neutrons inside a nucleus. So we have 9 protons and 10 neutrons, and we're going to draw a nucleus around these two subatomic particles. We learned that the electrons in an atom are located in orbitals around the nucleus. So we'll draw the first orbital. We have to place 9 electrons in various orbitals around the nucleus. Now the first energy level can contain a maximum of 2 electrons. We place one at the top and one at the bottom. Now I want to use a hotel analogy for filling in the electrons in the orbitals around the nucleus. Let's assume that the first orbital is the first floor of a hotel. And in the first floor, there is the front desk, perhaps a restaurant, but only one room. And in this room are 2 single beds. So if you were filling in the electrons, they would all have to go in this one room, each electron getting its own bed, one here and one there. Now all the remaining electrons can go in the remaining floors of the hotel. And each remaining floor has 4 rooms. And in each of the 4 rooms, there are 2 single beds. So there can be a maximum of 8 electrons in each additional floor. And the hotel manager is pretty strict about how you fill them in on the remaining floors. Make sure that you give each electron its own room first, and then start doubling up until that entire floor is filled. So let's start. We'll place 1 electron in the first room. We'll place the second electron in the second room, the third electron in the third room, and the fourth electron in the fourth room on the second floor of this hotel. Now before you can place any electrons in any other hotel floor, you have to fill up this floor. So let's start adding additional electrons, this time doubling up in each of the rooms. So we'll place another one in the first room, another one in the second room, another one in the third room, and we are done. We have added 9 electrons to the energy levels, 2 on the first floor and 7 on the second floor. So this Bohr-Rutherford diagram for fluorine is complete. Let's review it. We drew our nucleus, and in the nucleus we have 9 protons and 10 neutrons. And the electrons have been placed in energy levels orbiting around the nucleus. The first energy level containing a maximum of 2 electrons, and every additional energy level contain a maximum of 8 electrons. In this case, the second energy level contains only 7 electrons. In the second example, we'll draw a Bohr-Rutherford diagram for potassium. So we have to follow the same steps. The first step is to determine the number of protons, electrons, and neutrons using the atomic number and the mass number. So let's figure this out. The atomic number of potassium is 19. Therefore, there are 19 protons in one atom of potassium. Since there are 19 protons, then there must be 19 electrons in a neutral atom of potassium. The number of neutrons is found by subtracting the atomic number from the mass number. So this would be 39 minus 19 equals 20 neutrons. So let's draw our nucleus. And inside the nucleus, we will place 19 protons and 20 neutrons. Around this nucleus, we'll draw the first energy level, and we'll place the first 2 of the 19 electrons. To add the remaining electrons, we'll have to draw in another energy level. Remember, in each additional energy level, there can be a maximum of 8 electrons. So we can start filling electrons in this energy level. Remember, place them in each of the rooms by themselves before you double them up. So far we have added 10 of the 19 electrons around the nucleus, but we have 9 more to add in. So we have to draw an additional energy level. We'll continue to add them in, giving each of them their own room before doubling up. So we filled in 18, and this energy level is filled. We have 1 more electron to draw in, so we have to add an additional orbital, and we'll place the last remaining electron here. Even though it's by itself, it's okay. This is what 1 atom of potassium looks like. The nucleus has 19 protons and 20 neutrons. The first energy level has 2 electrons. The second energy level has 8 electrons. The third energy level has 8 electrons. And the fourth and final energy level has a single electron. Use these steps to draw Bohr-Rutherford diagrams of any element on the periodic table.